All right, page 3. We're going to find the general solution of second-order differential equations. We have y double prime minus 3y prime plus 2y equals 0, so a differential equation with constant coefficients. So I'm going to go ahead and substitute in my m's, and so for y prime I get m squared minus 3m plus 2 equals 0. And then I'm going to go ahead and factor, which I know this factors to m minus 2 and m minus 1 equals 0. So that gives me two solutions where I have an m, and I'll call that m sub 1 equals 2, and I'll say my n sub 2 equals 1. So that gives me my first solution. It's going to be e to the 2x. My second solution is going to be e to the x. So therefore, my general solution is just going to be y equals c sub 1 e to the 2x plus c sub 2 e to the x. And that will be my first solution. Again, you could have had c sub 1 e to the 2, c sub 1 e to the x plus c sub 2 e to the 2x. All right. So this is my solution to that second order differential equation with constant coefficients. Going to example 3, again we have the same thing, so I'm going to substitute my m's, and so I'm going to have m squared minus 10m plus 25 equals 0. When I look to factor that, what I see is I'm going to get m minus 5 squared. So here I have repeated roots where my m sub 1 and my m sub 2 is going to equal 5. So then I know that my y sub 1 equation is just going to be e to the 5x, and my y sub 2 equation is x e to the 5x. That gives me a general solution, y equals c sub 1 e to the 5x plus c sub 2 x e to the 5x. Example 4. Y double prime plus 4y prime minus y equals 0. So I'm going to substitute in once again. I get m squared plus 4m minus 1 equals 0. When I look to try to factor that, I realize that I can't, so I'm going to move to the quadratic equation, and I'm going to say m is equal to negative b plus or minus the square root of b squared, which is 4, so 4 squared is 16, minus 4 times negative 1 times 1, so 4ac is going to give me plus 4 all over 2a, which is 2 times 1. So then this is just going to reduce to negative 4 over 2 is negative 2, plus or minus the square root of the 16 plus 4 is 20, so I can pull out a 4, and then when I pull out a 4, it's going to be 2. 2 divided by 2 is going to be 1, so then I'm just going to have square root of 5 underneath the radical. And so now I've found my m sub 1 and my m sub 2. M sub 1 is going to be negative 2 plus the square root of 5, and m sub 2 is going to be negative 2 minus the square root of 5. And because these are real roots, they're not complex, then I'm just going to go back to my solution as y sub 1 is equal to e to the m sub 1, which is negative 2, plus the square root of 5x, and my y sub 2 is e to the negative 2 minus square root of 5x. And my general solution is just y equals c sub 1 e to the negative 2 plus the square root of 5x plus c sub 2 e to the negative 2 minus the square root of 5x. And that is my general solution for that second order differential equation. All right, moving on to the last one. I have 2y double prime plus 2y plus y equals 0. And again, I'm going to substitute in, so 2m squared plus 2m plus 1 equals 0. When I look to find the solution to find my zeros, I realize that I'm going to again have to use the quadratic formula. So I'm going to say m is equal to negative b, which is going to be negative 2, plus or minus the square root of 4 squared, so 4 minus 4 times a times c, so I'm going to get minus 8, and all over 2 times a, which is 2, so 4. And so when I solve for m, I realize that what I'm going to get is negative 1/2 plus or minus, I'm going to get negative 4 underneath the radical, which square root of 4 is 2, but I have a negative, so it's going to be 2i. So then I'm just going to have I over 2 for my solutions. So now I realize these are complex roots, which isn't bad because I know the form that it needs to be in. So all I need to do is find my alpha and my beta. My alpha is going to be the first term, which is going to be negative 1/2. And my beta is going to be the term with my I. So it's just going to be 1/2. All right. Now, I know that the form that it needs to be in is y equals e to the alpha x times c sub 1 cosine beta x plus c sub 2 sine of beta x. So now that I know that, I'm going to be able to substitute in my alpha and my beta. So then my solution is just y equals e to the negative 1/2 x times c sub 1 cosine of beta times x, which is x over 2, plus c sub 2, which is going to be sine of x over 2. And there's my general solution. So even when you have complex roots, it's not going to make your answer that much more difficult. And that does it for page 3.